Okay.
Alright, well, a good place to start. What are you working on now?
What am I working on now? Well, if you look at the ideal code up there, I'm actually calculating how bright some. I'll take a picture. Look, I've got a paper in front of me here. I've got pictures of some astronauts. A nice picture of dust in our Milky Way galaxy, and I'm calculating how much dust there is in a certain region where stars are being formed. So I'm basically writing a computer code to do some calculations to analyse some data. That's what it comes down to.
Okay. Cool. Awesome. How long have you been working on that? Is that like
Well, this is part of a project which I've this particular project for the last couple of years, and it's using the main part of it is using a telescope in Australia called MOPRA, and I'm actually making a new map of the galaxy in molecules. I'm making a molecular map of our Milky Way galaxy.
Oh wow.
And we're it's like charting the skies. We're making a new kind of chart in a new way of what our galaxy looks like.
Not something you can knock over in overnight.
No. In fact, it will take about 5 years to do the survey we want to do if all goes well.
5 more years?
Well, we've done 2 years, probably another 3 years to get the data set we're after. I mean, we're not working continuously all the time, but each year we get about a month of telescope time, and so to get the whole project done will take in the end about 5 months. So that's going to take about 5 years of actual clock time to collect.
Okay, cool.
And do you usually work independently, or with a group of other workers, or?
You pretty well always are working with other people. I mean, while you're working by yourself right here, I have many collaborators. So, for instance, the paper I'm working on right now, which is probably sitting here, has got there's a paper here. But a dozen or so authors or something on it. Who are some of them are in here, and some of them are overseas, and some of them elsewhere in Australia. They're all over the place.
Do you have any commitments to like teaching or anything like
Oh
that?
yes, absolutely. That's a big part of the job here.
Okay.
Yeah, like I mean, I have at the moment I've got 4 different lecture courses I'm giving over the course of the year, for instance. So,
Okay.
So yeah, you won't be getting. I mean, I used to teach the 1A course, but I'm not teaching. But actually, I am teaching it next session. But you would have moved on. You might get to see me in probably third year honours year. If you're still doing physics, that's when you're likely to see me as a lecturer.
Yeah. So what's your most favourite place or most memorable moment your career has taken you?
Memorable moment, my goodness. Probably the first time I went to Antarctica, I would say. That was probably when I was a junior academic here. I came here with an idea of a project in mind, and I got to go to Antarctica to try it.
Oh, that's great.
Awesome.
And we're still working there. 20 years later, we're still working on that project in ways I could never have imagined at the time.
Okay, cool, awesome.
And what kind of stuff did you do at Antarctica?
Well, we're trying to ultimately want to build new telescopes there, which can do things you can't do elsewhere because of the very special conditions that Antarctica has. It's a very cold, very dry place, and it's the next best thing to space in terms of putting a telescope up and looking out. But of course, it's also very challenging, and so it's not easy. So we're going there and doing small steps along the way, but ultimately we hope we will one day have a big telescope in Antarctica which can carry on some of the research that we're trying to do.
So would you describe your career or field of study as something that requires a lot of travelling overseas?
Well, I guess that's true. I went. I think I had 4 overseas trips last year.
4, okay.
Well, you had 1 this year, and I'm off in a month's time for a 6-week trip. So yes, that's the short answer. Yeah, look, I'm going off. I'm doing field trips to telescopes, and I'm going to conferences, or I'm meeting colleagues. I mean, yes, there's quite a lot of travel in scientific research. That's sort of part of the way it works.
Do you always meet the same people?
Not always the same, but it's certainly true that I might see the same person in 3 different continents in the world during the course of the year because they happen to be going to the same things I'm going to. That's so yes and no.
So it is like a large scientific community.
Well, it's a large scientific community, but those people working in your particular field might just be a few tens or 100 people or something like that in the particular specialist area that you're an expert in. So, I mean, for instance, I've got a collaboration which involves ourselves, a Japanese group and a German group, and I remember having meetings with the German and Japanese PIs in China last year, and was it Germany and here. I think we had 3 places. We all happened to be in the same places and in similar times. That was what it was. So,
Okay. Definitely log up the frequent flyer points.
well, yes, a few of those, yes.
So, what would you consider are the best and worst of your field of study,
The best and worst. You mean in?
or as your job?
Oh, I'm in a job. Well, I mean, the best is the chance to come up with ideas and try them out and explore them, and it's literally taken me to the ends of the earth to do experiments which I've dreamt up myself, and so that's great, and the opportunity to do that is a fantastic one, and I'm pretty privileged to be able to do that. The worst, well, I mean, there's nothing actual bad about astronomy itself when you're lucky enough to do that. I guess, like all things in life, though, of course, the astronomy is only a small fraction of the time I'm here. I mean, I'm obviously involved. I've got a lot of other jobs you have to do, administration and teaching and management, and sometimes some parts of those jobs, I mean, no one likes marking exam papers. You don't like doing them, and no one likes marking them. So but that's one of the things that has to happen in life.
So, you said that you actually have to apply new ideas to this area of science. So does astronomy and astrophysics require a certain element of lateral thinking?
Yes, I think that's a fair way of putting it. I mean, it's both lateral thinking, but also so methodical thinking. I mean, you've got to think logically. You've got to be very careful about what you do, but at the same time, the inspiration to sort of link 2 things together, which can be very disparate, that indeed could well involve lateral thinking. But it's not lateral thinking in the way an artist might put some abstract painting together. There's got to be some logical connection as well between the 2. You can't just think anything up.
Yes. Okay. No worries.
Right, so what would you consider your magnum opus, like your biggest work?
You mean my biggest scientific output? That's a good question. I'm not sure.
Too much to go through?
Well, there's a lot to go through. Probably the one that's most cited, I guess cited is the word other people have referred to.
Oh, yeah.
Is actually a theoretical study I did when I was a young postdoc. I mean, just after my PhD, and I was working for NASA at the time, and I wrote this paper up, which was basically a theoretical model for describing how some particular regions in some molecular clouds in space, how they emit, how you could sort of see them across the spectrum, and basically a theoretical model predicting the intensities of the emission in a variety of conditions, and that one's been very well cited, and has been a sort of fairly important part of moving the field along. So, but that was a theoretical study. It wasn't going out and using a telescope. That one.
Okay.
I think I'll stop it there.